physical and chemical properties and changes. So as you can see on this first slide, we have some chemical changes happening. That first video on the left of the screen is my absolute favorite. So what is a property? A property is a description. So for example, my shirt is periwinkle, my cardigan is black, I'm short. Those are all properties because they are descriptors. So like you see on the screen, the tree is green or the tree is tall. Those are properties of the tree. Physical properties are determined by the use of the 5 senses, okay? And they are a description of an object. And as we know, the 5 senses are sight, hearing, smell, taste, and touch. So here are the examples of physical properties: color, smell, taste, hardness, state of matter, boiling, freezing, or melting point. Those are all examples of physical properties. You can see these things, you can touch these things, taste them, smell them. They're physical properties because they use one of the 5 senses. Okay, some examples of physical properties again. Density, how dense is something? Mass, how much does something weigh? Volume, how much space does something take up? Malleability, which means how easy it is to mold something. So for example, foil is malleable because it's really easy to form to whatever you want it to. And just like the clay in this GIF, however you want to say it. And solubility. Solubility means how well something dissolves in water. Now, chemical properties, the fun stuff, are determined by a substance's ability to react with other substances. So a good example of a chemical property is fireworks. It's a chemical reaction that releases light. So here's some examples. The ability to react with air is rust, to tarnish, to corrode, or to rot. The ability to react with water or acids, and the ability to catch fire, which means flammability or combustion. You might hear that word as well. So again, these are chemical properties. When something rusts, tarnishes, corrodes, rots. Whenever water reacts with acid, it gets hot and kind of bubbles. And then flammability and combustibility. So here's a question for you. Is this a physical or a chemical property? The color of a beautiful sunset. That's a physical property because we see it with our eyes. If you use one of your 5 senses, it's a physical property. The ability of a nail to rust. Well, we just talked about that. Rusting is a chemical reaction with air. Therefore, it is a chemical property. The shape of a leaf. Okay? Do you use one of your 5 senses or not? That's kind of how I judge it. We do. We can see the shape of a leaf. We can touch the shape of a leaf. Therefore, it is a physical property. The ability of wood to burn. Now, we do see fire with our eyes. We can feel it. We can smell it. But the process of something burning is a chemical property. Okay? The hardness of a diamond. We can feel that with our hands. There's a test where you scratch against glass, or I guess it could be really anything. It's a hardness test, and that is a physical property. The volume of your Coke. Volume, we measure it. We can see it with our eyes. It is a physical property. There's physically that much Coke in your glass. The mass of 2 camels. Mass is a physical property. Okay, now let's talk about physical and chemical changes. So physical changes is a change that occurs without changing the identity of the substance. No new substances are formed. So, for example, this cat tearing up the toilet paper is a physical change. Yes, it is still toilet paper, but it does not look the same. It changes the identity, but not what it actually is. All right, some examples of physical changes are change in size, shape, color, sharpening a pencil, ripping paper, crushed ice, sugar dissolving in water, and painting a wall. You are changing the physical appearance of something, but not changing what it actually is. No matter what color these walls are, it's still a wall, okay? Chemical changes, a change that occurs that causes the identity of a substance to change. Something new is formed. The new substances with new properties are formed. All right, here are some evidences of chemical changes. So a new color appears, so a change in color, like in that first slide, how it went from red to black, that's a chemical change. It changed in color. Bubbles or fizzing, a precipitate forms, which means it's a solid material that forms. And then heat is produced, so if you touch the outside of a beaker, it'll feel warm. Light is produced. Sound is given off. And it's difficult or impossible to reverse. So when we talked about wood burning, yes, we see it with our eyes, we can feel it with our hands, we can smell it, but you can't unburn something. That's why it's a chemical property or a chemical change. All right. So here are some reactions of acids. Vinegar and baking soda, when you mix them together, it produces carbon dioxide gas. So we see fizzing, we see bubbling, and you can probably see a little bit of smoke coming off as well. Okay, reactions with oxygen is called oxidation. Makes sense. It's whenever oxygen reacts with iron and it causes things to rust. Reactions between substances. So sodium and chloride, when they come together, it makes table salt. Silver and the sulfur in the air causes things to tarnish. Tarnish means to make like dull and not as shiny, like how you see on the silverware down there. Some more examples are burning wood, metal rusting, your food digesting, gasoline burning when you drive a car or a tank or whatever, and baking a cake. Is this a chemical or a physical change? Ice on a lake melts to become water in the lake. Next, charcoal in a fire turns to ash after several hours. Think if you can reverse that or not. A pencil is sharpened in a pencil sharpener, leaving behind shavings. A battery makes electricity to turn on a flashlight. A bicycle rusts when left in the rain. A shirt is accidentally torn in the washing machine. A log is split in two by an axe. So that is all. Good luck, everybody. I will see you next time. Bye.